The age-old question, are we truly alone in this universe? The James Webb Space Telescope has discovered some terrifyingly human-esque things far, far away from Earth that lead us closer to the answer. Our search for life outside of our planet has been rampant throughout each human civilization, so much so that we have thousands and thousands of media, literature, and theories on this subject. Our wonder regarding our place and loneliness in the universe has been constant, as if it is ingrained inside of us to always search for a companion, no matter how alien-like. Well, we just might be getting closer to the answers we truly want. But are they truly the answers we are looking for, or are they much more terrifying? Join us as we explore the latest discovery in the realms of galaxies and planets on the quest to find something we just might not be prepared to witness. Lights far, far, far away, scientists have discovered what could be the most groundbreaking discovery in history. Back in 2021, when the James Webb Space Telescope was scheduled to launch, a very interesting hypothetical question was raised about the capabilities of our technology. The question was whether, in the future, our telescopes could detect artificial light on another planet. For example, Proxima b, the closest exoplanet to Earth, is in the habitable zone of our nearest neighbor, the dwarf star Proxima Centauri, about 4.25 light-years away. Since the exoplanet is 20 times nearer to its star than the Earth is from the Sun, Proxima b is believed to be tidally locked with a permanent day side and night side. This is similar to our Moon, which faces Earth with the same side at all times. A hypothetical technological civilization on Proxima b might transfer heat and electricity from the day side to the night side using photovoltaic cells that generate electricity out of starlight. Subsequently, in a paper with Manusvi Lingam as one of the researchers, it was shown that significant coverage of the day side by solar panels could be detected with future telescopes. Since JWST is more advanced, it would allow us to extend our search for artificial lights to habitable exoplanets like Proxima b. Now, in 2024, it is possible that the James Webb Space Telescope did just that. Using its higher sensitivity and bigger range of capabilities, the JWST might have discovered the lights we were looking for and possibly hurled us into another big surge of human evolution. But first, let us dive into the world of planets and exoplanets to learn how all this was even possible. Throughout history, humans have wondered about the nature of the universe. What we are, where we come from, and where we go are common yet extremely difficult questions man has tried to answer as soon as he gained consciousness. Now, in the age of exponential technological advancement, one does wonder if we are any closer to any of the above questions. If you ask a philosopher, he would probably say we are still at level 0 of understanding ourselves and the universe. However, ask an astronomer the same thing and watch him jump up and down in excitement as he rushes to tell you the latest discovery humans made about the universe using their nifty tools. These tools, although not paid much attention to by the average public, are quite literally a manifestation of human evolution itself. We now have the world at our fingertips, and it is time we move forward and get the universe at our fingertips as well. One such way to do that has been deduced by scientists and astronomers. It is through the technology we harness. A specific creation of that said technology is now responsible for the recent discovery of what might be light on a different planet, light-years away. Yes, we're talking about the James Webb Space Telescope. The James Webb Space Telescope is the creation born out of the legacies of human expeditions into space to answer some ever-present questions. Are we alone? Who is out there? Where do we begin and where do we end? Well, this infrared astronomy tool has already begun answering these questions, although partially. First, you might find yourself asking, what even is Proxima b? Proxima Centauri b, or just Proxima b, is sometimes referred to as Alpha Centauri cb. It is a super-Earth exoplanet, and it orbits an M-type star. Super-Earth exoplanet? M-type star? Confused yet? Do not worry, as this will quell all of your burning questions. Super-Earths are a class of planets that are more massive than Earth, yet lighter than ice giants like Neptune and Uranus. They are truly one of a kind. They can be made up of gas, rock, or even a combination of both, and their sizes can vary from twice the size of Earth all the way to 10 times its mass. They really put this super in Super-Earth, huh? As for Proxima b, it is a super-Earth and an exoplanet, meaning that it is a planet that traverses outside the solar system. The very first possible evidence of an exoplanet was found in 1917, although it managed to stir up little curiosity and recognition. However, in 1992, the first confirmed detection occurred, which left scientists speechless. Another exoplanet, a different one which was first detected in 1988, was confirmed in 2003. As of the 1st of April 2024, there are 15,653 confirmed exoplanets in 40,161 planetary systems, and out of them 896 systems had more than one planet. These marvelous discoveries are orbiting an M-type star right now. To explain the M-type star, you need to understand the red dwarf. A red dwarf is the smallest kind of star in the main sequence, hence the name. In the nearby regions of the Sun, red dwarfs are by far the most common type of star to be found in the Milky Way. They have really low luminosity, and since luminosity is one of our main tools for planet detection and other types of deductions, red dwarfs are not that easy to observe. These sneaky stars have variable definitions and names depending on their temperatures and sizes. For example, M-dwarfs or M-type main sequence stars yield a maximum temperature of 3900 K, hence getting their name and attributes. Coming back to Proxima b, its mass is known to be equivalent to 1.07 Earths. Interestingly, it only takes 11.2 days to complete one orbit of its star compared to our 365.25 days. You can estimate the size of the star Proxima b is orbiting, staggeringly under the measurement of the entire electromagnetic spectrum. The star has a total luminosity of only about 0.16% of the Sun. Additionally, in the visible light spectrum, its luminosity seems to dull even more as it appears fainter, only illuminating 0.056% of the Sun's luminosity in the visible light spectrum, emitting a significantly lesser amount of light energy when compared to the Sun. Over 85% of its emitted energy is in the form of infrared radiation. Orbiting about 0.0485 Australian dollars away from its star, Proxima b's discovery was announced way back in 2016. You might be wondering why Proxima b. Millions of stars, planets, and galaxies exist, so why are we so fixated on this particular celestial body? Well, there are a few reasons that contribute to the keen interest astronomers have in this place. First and foremost, Proxima b is the closest known star to our Sun. By definition, although 4.2 light-years is a big number to us Earthlings in the grand scheme of the universe, it is a mere blip. Hence, why Proxima b, our closest known star, is high up on the priority list at the moment. It is also part of the triple star system called Alpha Centauri. Although Proxima b's luminosity is very low, the system itself appears as one of the brightest constellations in the night sky, only behind two others called Sirius and Canopus. However, the most interesting thing about Proxima Centauri b is that it might potentially be habitable since it falls under the habitable zone. The possibilities surrounding this star are endless, and thus, astronomers have taken on the expedition to explore the depths and limits of the potential of this star. That is where the James Webb Space Telescope comes in. The four key goals of the JWST are to search for light from the first stars and galaxies that formed in the universe after the Big Bang, study galaxy formation and evolution, understand star and planet formation, and to study planetary systems and the origins of life. As the JWST continues its exploration of the said exoplanet, we get closer and closer to the completion of these missions, from SETI to exoplanets searching for alien life. So what exactly is SETI? It is a collective name for the scientific searches for intelligent extraterrestrial life. It began as an exploratory science that seeks evidence of life in the universe by looking for specific kinds of signals. In the early 1900s, pioneering scientist Nikola Tesla suggested that radio could be used to contact extraterrestrial life on Mars. On August 21, 1924, a favorable opposition of Mars took place. As a result, the U.S. Navy directed all of its radio stations to monitor for any signals from Mars. At the same time, a more direct but ultimately equally fruitless attempt to communicate with Mars via radio transmissions also took place in 1924. This set the tone for the decades to come. In the 1960s, Ohio State University made headlines with the first scientific search for alien life, named Project Ozma. It was an unsuccessful attempt to look for signs of life among two nearby stars. However, as a result of this search, the scientist Frank Drake drew up the famous Drake equation, which estimated the number of possible intelligent civilizations in the universe. These efforts marked the beginning of a long-standing quest to detect alien life. From detecting radio waves and other electromagnetic signals to listening for alien conversations, SETI has evolved significantly. Today we are on the brink of a breakthrough. In a 2021 research paper, scientists investigated the possibility of detecting artificial lights on the dark side of Proxima b, which might potentially indicate the existence of intelligent life. The study aimed to assess whether Proxima b might sustain intelligent life, and if it did, how such life could be detected. Now, in 2024, with the powerful James Webb Space Telescope, we are closer than ever to answering these questions. The telescope's advanced instruments can detect faint signals and lights, making it possible to spot artificial lights on Proxima b. One of the key instruments on board the JWST is the near-infrared spectrograph, which is designed to detect faint signals from distant objects. This instrument, combined with the mid-infrared instrument, enables the JWST to study the atmospheres and environments of distant exoplanets like Proxima b in unprecedented detail. However, the habitability of Proxima b remains uncertain due to the luminosity evolution of its M-dwarf host star. M-dwarf stars can have extended pre-main sequence phases, emitting high levels of radiation that could strip away the atmospheres of forming planets. Despite these challenges, the JWST's advanced technology offers hope. Its large aperture and state-of-the-art detectors allow it to capture subtle variations in light, providing insights into Proxima b's surface properties, climate, and potential signs of geological or atmospheric activity. As we continue to push the boundaries of space exploration, the future looks bright. NASA's Artemis program aims to land humans on the Moon in 2025 and establish a long-term presence, paving the way for future missions to Mars and beyond. Private companies like SpaceX also have ambitious plans, including the colonization of Mars. As the James Webb Space Telescope continues its mission, we may soon have definitive answers about the existence of extraterrestrial life. Are we truly alone in the universe, or are there other intelligent beings out there? The discoveries we make in the coming years could change our understanding of the cosmos forever. What do you think? Are we close to finding extraterrestrial life? Share your thoughts and opinions in the comments below. Don't forget to like, share, and subscribe to Space Discovery for more fascinating insights into the mysteries of the universe.